Now that we have introduced our angles on a Cartesian plane, we've looked at the signs of the different ratios, and let's just quickly do a summary of the cos diagram, and then we're going to do just a fun experiment together, which is so good for understanding what it is when we're working with trig, and then we'll jump into doing some examples. So this is our quadrant 1, 2, 3, and 4, so it's important to remember that. And our cos diagram is just an acronym to remember which ratios are positive where. So cos diagram, which means in the first quadrant, all our ratios will be positive. Sine, cos, and tan will all be positive because in that quadrant, our opposite and our adjacent, our x and our y, are both positive. In the second quadrant, only the sine ratio will be positive. Tan and cos will be negative. In the third quadrant, only tan will be positive. And we saw that when we looked at our unit circle and we moved those points around. Only tan will be positive, sine and cos will be negative. In the fourth quadrant, cos is the only ratio that will be positive, and sine and tan will be negative. So it's important to remember and to help you determine that which quadrant we are working in. Grab your calculators and do the next experiment with me. All right, look what we've got over here. Let me label them that we know exactly where we're at. In diagram 1, we are in the first quadrant where we know that all ratios will be positive. Now, if I put into my calculator sine 30, that gives me a half. So sine 30 gave me a half. Okay, great, which is my opposite. So in this case, my opposite must be 2 over hypotenuse there, which is 1. Okay, let's go to the second quadrant. According to our cos diagram, we know that sine will have a positive ratio in the second quadrant. Now, do you notice over here that I created the exact same triangle in the second quadrant? Why is that? That angle over there will also have a 30-degree angle because 150 plus 30 is 180. So if I go put into my calculator sine 150, because that is the angle that's forming, right? That gives me sine 150 gives me a positive a half, because the 150 tells my calculator that I am in the second quadrant, but it is exactly the same triangle. We're just putting it in a different quadrant, which means the signs are the only things that's going to change. The ratio is going to stay the same. And I'm also just showing you this, grade 10s, because it helps with understanding, because every now and again, students are given questions, let's say in this quadrant, and then the theta is given there. And then they feel confused. They're like, okay, but what is this angle over there then? So it's for them to understand that actually you can also just put that theta in there as well. So we can put the theta there, even though that theta over there is 150, that acute angle over there would be exactly the same as the acute angle that forms there. All right, let's head over to the third one, where in the third quadrant, according to our cos diagram, we know that sine will be negative in that quadrant. Okay, so let's have a look. Can you see that I created the exact same triangle over there, where that is 30 degrees again, because 180 plus 30 is equal to 210. So it is a congruent triangle to the previous ones. So we know that the ratios for the sides must be the same. So this would be sine 210 is equal to, if you put that into your calculator, it gives you negative a half. The ratio is exactly the same, but because we are working in the third quadrant, that's why the ratio would be negative. If we go to the fourth quadrant, I created a congruent triangle there. How did I do that? Well, I know that that angle over there would be 30 because that theta over there going round is 330 plus my 30 degrees there gives me 360. So it is a congruent triangle. Put into your calculators sine 330, and that gives you negative a half. Sine 330. And we knew in the fourth quadrant that sine will be negative there because only cos is positive in the fourth quadrant. All right, shall we do another one? I hope you said yes. All right, there is one more. Let's have a look in the first one. Let's use a different ratio with this one, actually. Let's use tan. Let me label them again. We're going to work like that. 1, 2, 3, and 4. So in the first quadrant, let's put in tan 50. And tan 50 gives us, 1,1917, blah, 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 and there are some decimals. Now, since these triangles are all congruent, and we're going to prove it as we go, we know that the ratio will be exactly the same because the triangle is the same, and the ratio of the sides will be the same. The only thing that would be affected is the ratio of the sign of the ratio, either positive or negative, depending on which quadrant we're in. Okay, so let's start with the first one. We know that tan is opposite over adjacent, right? We know it will be positive in the first quadrant. Let's look at the second one. How do I know it is a congruent triangle? Well, 130 plus my 50 degrees over there will land me up at 180, which we know the straight line is. So put into your calculator tan 130, and that will give me tan 130 will give me negative. So it's the exact same ratio, but it is just negative because in the second quadrant, your tan, according to our cos diagram, will have a negative ratio. Onto number 3 rather, into this triangle, that acute angle over there is 50 again. It's a congruent triangle. Why is that? Because if I take from there to there is 180, the straight line, right? And if I plus 50 degrees to that, it would land me up at 230. That gets me all the way into the third quadrant. Now, in the third quadrant, we expect our tan ratio to be positive because we know that from our from our cos diagram, because our opposite over adjacent, they both will have negative values. Your x will be negative and your y will be values. So that for that point, your x would have a negative value and your y would have a negative value. And if we divide that, that would give us positive. So if I put in tan 230, yes, that would give me the exact same ratio because the triangles are exactly the same size. They're congruent. So the ratio between the sides must stay the same, but it will be positive in this quadrant. And then in the last quadrant, so over here, how do we know the triangles are congruent? Well, that little angle over there must be 50 because 310, that gets me to that position where I'm at on the unit circle, plus 50 would get me to my full revolution of 360. So definitely congruent triangles. And in this quadrant, according to the cos diagram, we know that our tan will have a negative ratio. But why is that? Because tan is opposite over adjacent. And in this case, my adjacent is positive, my opposite is negative, so it will give me a negative ratio. So put in to your calculator tan 310, which is equal to negative 1,191. And there we go. Using your trig ratios on the Cartesian plane. Now let's get on to doing some problems and seeing how we're going to use all these ideas.